So let's have a look at some of the vulnerability management problems. Okay, so as you can see from this chart, these are the number of vulnerabilities that are getting released every year. Right? So if you have a look back in the early 2000s, there was around 2,000 vulnerabilities that are getting released every year, and obviously much more manageable than today, whereas when you look at it, there's over 20,000 new vulnerabilities getting released every day. And that means that it's not 20,000 that you need to be looking at and managing, it's cumulative, right? So it's not that you've got everything patched beforehand, because every penetration test that we've done over the last 20 years, there's never been a clean report. So it's cumulative, so it's adding up, and that's not just across one system, it's across every system. So if you then have 100 or 1,000 or 10,000 systems that you've got to look after, that's a huge number of vulnerabilities that you've got to stay on top of. So some of the challenges with doing that, obviously beyond just vulnerability overload, which is what everyone's feeling at the moment, and ultimately the reason why things aren't getting patched, is also the approach that's getting taken. So traditionally we used vulnerability scanning, which is still to a degree relevant and a component to the exploitability. But what you find with vulnerability scans to identify the vulnerabilities is that there's a huge number of false positives or a huge number that are not exploitable, right? So what you need to keep in mind is that even if you're vulnerable, it doesn't mean that you're exploitable, right? So a lot of these vulnerabilities that we're looking at, that are getting released, may be vulnerabilities, they may be valid, they've obviously been allocated a CVE, but it doesn't necessarily mean that they're exploitable, right? And that really comes down to a whole bunch of different factors, which we'll talk about later, to actually get an exploit working. And this is some of the stuff that we teach in our Black Hat course. So when you get a vulnerability scan, especially when you're doing authenticated vulnerability scans or using agents on machines, you get a massive number of false positives, and the authenticated ones give you a multiplier of vulnerability overload, because the majority of vulnerabilities that you will see are inside your operating system, and the software that you're running on those, which again, if the attacker can't actually connect to those in the first place, they're actually not exploitable. So, but when you even look at these, there's a huge number of false positives, especially when you're doing sort of network-based tests, because there needs to be certain circumstances that all line up in a row for an exploit to actually work. And therefore, even if you look at things like PHP is a good example, or Apache, for example, where there's massive numbers of vulnerabilities that come out, but the actual reality of exploiting those is very, very small. So we tend to see probably 99% of vulnerability scans producing either false positives or they're not actually exploitable. Companies are getting 3,000 pages, if not more, of vulnerability scan reports, which are just not humanly consumable, but the majority of it is false positives, and you shouldn't waste your time actually fixing it. The other part of it is that it's not exploitable, and some of the reasons why it might not be exploitable is because the vulnerability might need a specific configuration to be in place. For things like Apache, for example, that's very, very common. It needs to have a particular module that's installed, which may not be there by default, but it's coming up in your vulnerability scans. It may also not be used by the application. It may be installed but not used. And same sort of thing with things like PHP, where you get a huge number of vulnerabilities, but unless your application is actually calling that function and using it in an insecure way and exposing it to the attacker, then it's not actually exploitable. And this is the problem that we're facing. We've got an exponential increase in vulnerabilities being released, and therefore overloading our security teams and our IT teams to try and chase their tail and get these things patched, but they're actually not exploitable. But there's also false negatives, and these tend to fall into a couple of camps. One is zero-day vulnerabilities, and we don't really expect vulnerability scanners to pick those up. If they did, they can be simple ones that they could potentially pick up, but in reality, finding remote code execution vulnerabilities through a vulnerability scanner is just not going to happen. And the other camp is false negatives, where the vulnerability scanners cannot pick it up. And the reason why they can't pick it up and they miss these vulnerabilities is because they're not doing exploitation. And some vulnerabilities need you to actually exploit the vulnerability to actually see if it exists. So Spring for Shell is a really good example of this, where a lot of vulnerability scanners, all of them will produce massive amounts of false positives for this type of, for Spring for Shell, and you have to be authenticated to get that false positive, right? The reality is, to detect Spring for Shell, there's about 4 different factors that need to be in place, and some of that is how the developer has actually written their code, right, which cannot be detected by the vulnerability scanner. What you need to actually do is actually exploit the vulnerability and upload a file to the web server, and actually see if you can get remote code execution through the backdoor that you've uploaded. And that's not going to be done by vulnerability scanners. And when you have a look at all this, as I keep saying, when you've got 99% false positives, and that's being lumped on top of an already small and overworked security team and an already small and overworked IT team, it's adding more burden unnecessarily on top of the limited resources and the time that you've got within your organization to actually do strategic activities to push the business forward. So it's an unnecessary overhead. All of this also leads to inaccurate executive or board reporting and management reporting. So when you start going to the board every month, for example, or to your CISO and saying, all right, this month we have 100,000 unpatched vulnerabilities, and there's 1,000 critical vulnerabilities that have been identified. You don't have time, or your IT team doesn't have time to actually go and fix those. There's also new vulnerabilities coming out the following month. And then you go back to the board, you may have fixed some of them, and you say, right, the next month we've got about 100,000 vulnerabilities, about 1,000 of them are still critical, and that keeps going on, right? What that's doing is, when you look at the fact that 99% of those are either false positives or not exploitable, if not more, it's probably closer to 99.9%, then you're actually incorrectly or inaccurately reporting up to the board the wrong position as to what your actual risk is for your business. Right, so what that then leads to is, all right, well, we don't have enough resources to actually, or time to actually go and fix these vulnerabilities, or we don't have the right technology in place to fix all of these 100,000 vulnerabilities that are false positives. And therefore, going and allocating additional budget, which might be great for the IT team or the security team to get extra budget, but allocating that budget to either resources or technology that are not adding any value to the business.